Alright, picture this. Imagine you're out in the wild, watching a forest fire. The wind picks up, and suddenly the flames race across the landscape, faster than you thought possible. But here's the thing, I can actually predict how fast that fire spreads, all with a bit of maths. Let's break it down. In forest resources technology, you often model the speed of a fire with an equation like this. S equals sine kW, where S is the spread speed, W is the wind speed, and K is a constant depending on conditions. If the wind changes, so does the fire. The magic happens with differentiation. If I want to know how much faster the fire will move if the wind picks up just a tiny bit, I can differentiate S with respect to W. In this case, it's pretty simple. The derivative ds dw is just K. So for every small change in wind speed, spread speed changes by K times that amount. But what if I flip the script to food science, specifically packaging design? Here, integration is my secret weapon. Imagine you're designing a food pack and you want to figure out exactly how much volume it holds. Let's say your pack is a cylinder. Classic shape, right? The formula for volume is V equals sine PR2, where R is the radius and H is the height. But what if you want to get fancy? A curved pack or something unique? That's where integration comes in handy. You can break your irregular shape into tiny slices, sum up all their volumes using integration, and voila, you get the total volume of the container no matter how wacky it looks. So here's the big reveal. Differentiation helps me understand how things change. In this case, how wind speed changes fire spread. Integration helps me add up little bits to get a big picture, like figuring out the total food volume in a complex pack. Whether you're saving forests or designing snacks, maths is quietly working behind the scenes. Pretty cool, right?